Okay, hey everybody. All right, so now I wanted to graph the log functions. So in the last video, or the last topic, I did exponential functions. And exponential functions always start right here and do a little like curve thing and hug the x-axis but never cross. All right, and log functions are inverses of exponential functions. Right, so if we wanted to graph log 3x, I do it in, yes, great, right? It's going to go right here because they're inverses. And it's going to have the y-axis. Okay, and so if we, it's beautiful artistry right there. But theoretically, if this is perfect, right? Actually, I can just show you my calculator. Okay, I'm going to show you without the base of 3. So I just type the 2 in. Okay. So this is 3x right here. Goes through 0, 1, and this is log x. It's going to go through 1, 0. And notice, if I folded on this like that, there we go, diagonal line right here, like that, this line right here, let me show you on the screen. If I folded right here, and these were like perfect, then these two would overlap each other. So the exponential function is at 0, 1. The log function is at 1, 0. Unlike all the other functions that we studied, these guys start at different starting points. All right, so same concept. He's, whoops, didn't be that start. And then he's over here, 1, 0, hugs the y. And if I were to draw a line of y equals x, and they would overlap each other. All right, and this describes how they all move the exact same way. If there's a number on the inside, it moves left or right, and it's opposite of what we think. So this guy is going to move left 3. So instead of starting right there, I'm going to go left 3. I'm going to start here. I'm still going to draw the same basic shape. So here, and if it's on the outside, if it's a constant, it moves up or down. And he's normal. He's going to go down 4. So instead of being right there, I'm going to go down 4. 4. And same basic shape. So all functions, whether it's log, exponential, quadratic, cubic, square root, cube root, all the functions, they move all the exact same way. It doesn't matter like what function is written right there. Let's do some more. All right, this just talks about common log, which is also called natural log, ln. There's a key on your calculator above the log function. Okay, and so right here, he's going to move right 2, because normally we think it would move left 2, but it's opposite. And so instead of being right there, he's going to go right 2. So he's going to be right here. And this guy's going to go up 5. Instead of being right there, he's going to go up 5. And same basic shape. And so when I ask you to graph, if you're just sketching it by hand, I just need that. If it's on the computer, you just are looking for like basically like this vertex, okay? And the shape of it. And you can type this like in your calculator to check to make sure you're right. So ln, again, is right here. Log is right there. You just type it. There he is. Let me put him back in Y1. ln x plus 5. And then we push graph. And there he is. You So it looks like he's right here, but he's not. If we zoomed in, it wouldn't be. Let me show you. He still looks like it. I promise you it's not touching. All right, let's look again. Some more properties. So we've talked about these guys. So here I talked about how, the base of log, this number right here is the base, is 10. It's an invisible 10. So right here you can't see the 10. Right here you can't see the 10. Here you can't see the 10. And so 10 to the 0 is just 1. 10 to the 1 is 10. 10 to the x is the same as 10x. Log 10 with an invisible 10, those just cancel. And so versus, which is how these also work, versus memorizing these, just kind of let's use our common sense as we go through. All right, ln. Okay, watch what, like, just type this in your calculator. ln. Okay, to get the e, I'm at my home screen. ln, and then to get the e, just put second ln, e, and it's just the number 1. I just get 1. Because remember, ln has an invisible base of e, and that e is right there. So those cancel. So I just get 1. So anytime I see ln e, it's just 1. So this guy is just 3x. And so that guy is just 1. Because e to the 1 is e. Right here, those cancel because there's an invisible base e by that ln. So we just get 4x squared. This right here is really. Okay, let's rewrite him. So he is 2 to the 3 equals x minus 5. Right, 2 to the 3 is 2 times 2 times 2, which is 8. 8 equals x minus 5. And then we're going to add 5 to both sides because we need x by itself. You need to break up with that x. All right, don't talk to that x. Once you've broken up with that x, no more. No more. Okay, there's a reason he's an x or she's an x. All right, so add 5 to both sides, opposite operations. We'll get 13. And so if we put 13 right here, 13 minus 5 is 8. So 2 to the third, 8. I just checked it, but this is your answer. Right here, 9 to the 9, those cancel, that's 1. So this is really log, let's make it equals x just to make you feel better. So this is really log 3 to the 1 equals x. So this is 3 to the x equals 1 because we rewrote it with exponential form. We ask ourselves, okay, 3 to some number is just the number 1, and exponential rule says it's 0. 3 to the 0 is 1. So x equals 0. So this is my answer. Okay, here, it's kind of sneaky. First, let's do this guy. This guy says log 5, 125. Let's call this x. So 5 to some power x equals 125. Well, 5 times 5 is 25. Times 5 is 125. So this x right here is really 3. 5 to the third is 125. All right, so log base 3. Okay, so this whole thing right here equals that 3. 3 equals, and we'll say, I don't know why. All right, and so just like here, when it's the same number, it cancels and it's just 1. So we get 1 is our answer. All right, this is a really good problem. Students in a psychology class took a final as part of the experiment to see how much of the course content they remembered over time, and they took equivalent forms of the exam in monthly intervals after. The average score of the group, FT, after T months is modeled by that guy right there. What was the average score in the exam? All right, well, the average score is 83, and then after that, each month after, it goes down. So what was the average score after 2 months? So we're going to do 83 minus 8. That looks really beautiful. 13 ln 2 plus 1. And I'm not going to overthink this. I'm just going to type in my calculator. 83 minus 13 L, nope. 83 minus 13 ln 2 plus 1. Right, 68.72. So that was the average score, 68.72 after 2 months. Right here. So this is something I would ask, like on a test, for example. This is not necessarily something I would ask on a test, but let's do it anyway. All right, so I'm going to type 83 minus 13 ln x plus 1. It's okay that it says t and we're using x. And when we push graph, we may not be able to see it. So make sure you push zoom. If you, like here, first let me show you what I typed in. Okay, so I just typed that guy in. And then here, you can't see it because our thing is 83. So we need to change our window. Okay, let's change everything to 100. So when you graph stuff, if you can't see it, you need to change your window, basically. There we go. So basically, it starts off at 83. We'll say that's 83, and it goes down. Okay, but this is something I would ask, definitely. Describe what the graph indicates in terms of the material. Sure. They forgot information over time. Because like they took the class, they took the final, and then every month for 12 months, they took the same final, but they're no longer in class. So they forgot stuff, right? Because they're not learning anymore. All right, so go do some practice work, and then I'll see you in the next video. Bye.